are live. Hi chat, hopefully you can all hear us properly. Tonight, well it's tonight for Mero and I and it's afternoon for Lizzie. We're going to be talking about cancer and some new discoveries in cancer. We're also going to be touching on the coronavirus as well. And our special guest with us is LIzzy Lang. I'm sure everyone knows Lizzie, but Lizzie, you want to introduce yourself?
So like Jen said, my name is Lizzie. I am a microbiologist and a biochemist that works at the University of Namibia. And I am currently doing my PhD in medical microbiology and analytical chemistry.
Cool.
So you are genuinely awesome.
Yes. And Mero, what have you been up to?
Not sleeping, apparently.
Okay.
I'm very tired, so I'm probably gonna crash very, very shortly. I'm just doing this. Gotta do it.
Now,
But other than that, I am doing a microbiology major as well as chemistry major at university. This is my final year, so Lizzie and I have similar thought processes.
so for once in my life, I'm the stupid one in the stream.
Yes.
Isn't
that like you almost every stream though?
Yeah, only when I'm drunk.
Yeah.
Okay. Lizzie, if you don't mind, Mero would like to actually start with the coronavirus stuff, and that's because she may have to head off soon, and it's a bit that really interested her. So I know this is about the cancer, but we can always shorten up some of the cancer stuff, and coronavirus is in everyone's sort of minds at the moment, especially with all the toilet paper everyone's buying.
Sorry, Lizzie. I know I'm just destroying the way we think, but
yeah,
it's
now she's got to search through her notes. Do you
want
me to pop up the window of why does the coronavirus spread so easily, so that the chat can see it?
Yeah, I always have all of my sources in front of me.
Well, this is one of Lizzie's sources. It's from Nature, and it's why does the coronavirus spread so easily between people. So I'll let Lizzie go with it.
Lizzie, you there?
Lizzie, you there?
Lizzie.
Mero, do you want to start?
Oh, Mero wanted to start with coronavirus because, in case she has, because she'll have to head off in a while.
Can you guys hear me?
Yeah, we can hear you. Can you hear us?
Yes.
Okay. Can you hear us, Lizzie? Lizzie. Yeah, unfortunately, Lizzie's got internet issues at the moment, and it's causing a few communication problems. So, apologies.
So why does the coronavirus spread so easily, Jen?
I don't know. I haven't read the article yet. Lizzie only sent it to me a little while ago.
Hi.
Neither have I.
Hey, Lizzie, can you hear us? Yeah, she's making stuff like there's audio.
On that exact
making noises.
Quickly, mic slow because they keep very overloaded.
Sorry. Okay, I missed what Lizzie said.
Okay. Then. She said that the internet is overloaded.
Oh, okay.
Okay, so what I'm.
Can you see this article, Mara?
I'm seeing the article. I have opened it up on my thing. So, I will try to explain as I'm reading. So I could probably get something wrong, and hopefully Lizzie will be able to explain what. Yeah. Okay. So basically, it's spiky. So when there's an infectious agent such as a virus, it produces proteins or glycogens, which are like sugars, depending on things, and they're spiky, and they go out and they sort of attach themselves to another the cell that it wants to infect, and it tells the cell that it's all right to go into the cell, and that's how it infects. So this is the coronavirus. It says to infect a cell, coronaviruses use a spike protein that binds to the cell membrane, which is what I was saying, a process that is activated by a specific cell enzyme. So an enzyme is a protein as well. If you don't know what a protein is, it's basically a chain of amino acids that's folded. Not necessarily folded, but generally they are folded because entropy causes that to happen. Genomic analysis of the new coronavirus has revealed that its spike protein differs from those of close relatives, suggesting that protein has a site on it which is activated by a host cell enzyme called furin. So basically that means that that the host cell, which is our cells, has a protein on the outside of it called furin, which is what attracts the coronavirus. Continuing on, it says this is significant because furin is found in lots of human tissues, including the lungs, liver, and small intestines, which means that the virus has the potential to attack multiple organs, says Li Hua. I'm assuming I pronounced that terribly, who is a structural biologist at Huazhong University, I think, of Science and Technology in Wuhan, China, where the outbreak began. This finding could also explain some of the symptoms observed in people with the coronavirus, such as liver failure, says Li, who co-authored a genetic analysis of the virus that was posted on the China XIV or China Shift. I'm sorry to anyone who's Chinese. I don't speak Chinese. I'm trying my hardest. I really am sorry. Preprint server on 23rd of February. SARS and other coronaviruses in the same genus as the new virus don't have furin activation sites, he says. Would I be, from what I just said about proteins and glycogens running around on the surface of viruses and things like that, that's pretty much right, isn't it, Lizzie?
Yeah, so basically viruses normally have specific little receptors. The coronavirus specifically has this little spike receptor that recognizes specific receptors on our body cells, which they then use basically to infect the cells.
Yeah. So it's kind of like a jigsaw puzzle, really, isn't it? It's very specific. It's very it's very targeted. It's I think remember that my brain is trying to catch up with me.
It's like most viruses are very similar in that, though. They have a particular targeting system that attaches to a certain part of the cells that they're aiming for. So in that sense, coronavirus is no different. It's the effects that coronavirus has that makes it different to other viruses.
Yeah,
so once it attacks,
because it's activated by an enzyme called furin. Every virus has is very specific. Yeah. So with microbes, you can get things called I had just had it, phages, bacteriophages, which is a virus that kills bacteria, and one specific virus kills only one type of microbe. So they're actually looking at using phages to target antibiotic-resistant bacteria and try and kill them and use them as a form of antibiotic because
that would also make it harder if there are targeted antibiotics for the viruses to build up an immunity as well.
Well, viruses aren't affected by antibiotics. That's a myth.
Well, that's true. Sorry, yeah.
Yeah. You've got antiretroviral. You've got virus. You've got drugs that do target viruses, but they're very, very hard to come up with because viruses technically aren't alive.
Yeah.
So you can't kill a virus. You can deactivate it, but you can't kill a virus, which is why we haven't found a cure for HIV yet. We can work on it to stop it from multiplying within the body, but we can't kill it because
it's not alive.
They're not. Yeah, it's not alive.
Yeah, it's more of a parasite than anything else. But the parasite's not really alive, but virus is a kind of non-living parasite.
Yeah, well, you can also use drugs on parasites as well, but the best way to
parasites are alive, but
the big weaknesses with most viruses is immunization. But even that's pretty hard. Like if you that's why you need to get your flu shot and stuff like that. It's very important to have that because once you've got the virus, there's nothing really that they can do for you except for telling you to go home and fight it off. But with something like HIV,
think of the media beat up over coronavirus?
I am furious. I'm absolutely furious. I think the media is being extremely unethical, extremely irresponsible.
Is not good. And
no,
it is literally
it's definitely
panic.
not.
The way people have gone out and bought toilet paper and canned foods and stuff like that, panicking because of this Armageddon of the coronavirus is just boggles my mind. It's like, yeah, you're going to be isolated for a couple of weeks, but it's only a couple of weeks.
Yeah.
You know, it's no reason to walk out of a shopping centre with a trolley full of toilet paper.
And the annoying thing is I actually have to get toilet paper. I'm down to my last 2 rolls.
It is so hard. I went to 3 shops the other day and managed to get 4 rolls. That was
congratulations.
So I was like, it's just nuts, and I'm like, this is crazy. There is no need for this. I can maybe understand if you're a bit worried buying an extra, because I guess most of us buy our toilet paper in bulk because it's cheaper. So you buy an extra bulk packet, not a trolley full of toilet paper.
No.
So
the other thing that people need to understand is that basically like 80% of the cases are mild. So you'll just have you'll be slightly more sick than you would be if you have like the common cold or the flu or whatever. So like 80% of cases are mild. So it won't really require a lot of medical attention. So people really need to like calm down. Also, like the death rate for like people ages from their teens all the way into their 40s is about 0.2%. It's very rare for young people to actually succumb to the virus, and usually it is people that have like pre-existing conditions that affects their respiratory system that has a harder time with it.
Yeah, you more or less have to be infirmed in the first place to be potential of dying from it. So.
And
also another reason why it's important for everyone to get their flu shot, because you do not want to get the flu on top of getting infected with the coronavirus. So please, everyone, get your flu shots.
Yeah.
Yes.
Get your flu
yes.
shots.
And one of the things that people don't tend to understand is that even though we were saying that viruses aren't technically alive, they do deactivate without a host. So if you think that, you might have received something like a package or something like that from outside, leave it alone overnight and it should be fine by the next day if the coronavirus or the flu virus like the coronavirus has the same deactivation time as the flu virus. If you just leave it overnight or 24 hours before opening it, then that should be fine as well.
And the
Yeah,
crazy things
remember
people have been
things like
worried
that.
about, like people were actually actively worried about bubble wrap that came from China because the air in the bubbles was from China, and I'm like, what?
Goodness.
I mean, it's injection molded anyway, so it's really hot. That's going to kill most things that is in that air. But aside from that, it's been in packaging for so long, it probably hasn't survived anyway.
It's not just that. Like, people have a misunderstanding because the coronavirus is not airborne. It is like spread by respiratory droplets. So for something to be an airborne virus, it needs to be able to be expelled from the body and then basically stay afloat in the air for it to spread. The coronavirus doesn't do that. It stays in the respiratory droplets. It needs to be in respiratory droplets in order to like spread from one person to another. It's not an airborne virus.
Yeah.
Yeah. Yeah, so that's, and also something that's really kind of concerning me is not only this panic, which is completely overblown and is irresponsible. Like, this is a really good opportunity for media outlets to start teaching people about epidemiology, to start teaching people about what it means when this does this. They give the facts without the context.
Yeah.
Which I have a big problem with, because I don't know if you saw the tweet that I put up a couple of days ago, Lizzie, about how I'm glad that like, if it was a disease that was actually killing off young, healthy people, that's a lot more concerning to me than what SARS is doing now. It's just humans are a part of, coronavirus. The problem, the thing is that humans are still a part of our species. We're still a part of nature, and what these diseases do is just knock off the weakest, and it's sort of, you could say it's a form of natural selection. I'm sorry to say that, it's a really harsh thing to do, but unfortunately that's the way natural selection works. And I don't mean to say that to mean to be disrespectful to the people who do unfortunately pass away from the coronavirus. But if it was something that was knocking off young, healthy people, like the Spanish flu did, that's a lot more concerning.
I definitely agree. The other thing is that people are freaking out because of the specific name that was given to this specific coronavirus. So the name of the virus is SARS-CoV-2, and the disease that it causes is COVID-19. So that SARS part is basically what is freaking people out. But SARS just stands for severe acute respiratory syndrome. So it just basically means that it causes acute respiratory problems. It is not like the original SARS virus. It's a relative, but it is not that extreme. So there is a reason why they named it like that, because it's technically a cousin of the SARS-CoV-1, which was the original SARS virus, but it doesn't cause those severe symptoms that the SARS virus did. That's why they named the disease COVID-19.
Yeah, and that's another thing that the media really should be reporting on, is sort of like explaining these sorts of things, rather than saying X amount of people have died over here and it's been spread to here, and been spread and spread and spread.
Don't those tallies just annoy you? All these people have died. Yeah, how many
people have had?
Yeah, how many people have had it? How fewer of those percentage of people have actually died? How small a percentage of the population is it actually that is getting this? The point is, most countries are getting on top of it reasonably quickly.
The other thing is as well, when people present mild cases, most of them are not going to actually report and go to the doctor and get tested. So there is a large underreporting of people that actually have it, meaning that the death rate is actually technically a lot lower than what is being reported.
Exactly. And also, one of the things that has come up a lot is actually how the American healthcare system is actually going to cause SARS to spread because people are too afraid to go to the doctor to get tested. So that's I think one of the positives about coronavirus, because if there's, there has to be a silver lining somewhere, which is to actually show people how important it is to have a good, robust health system, which America does not have.
Oh, great.
So,
I mean, we had this
think,
discussion on Twitter today with somebody where they were saying that, oh no, we don't need that, and we're like, no, you need a proper healthcare system for everyone.
Yeah, exactly.
Healthcare's a right, not a privilege.
It is actually a right. It's on the international human rights. It's a part of the human right to be able to access healthcare.
Yeah.
The other thing that I also wanted to just like quickly talk about is basically people buying face masks, like the masks that they basically use for doctors and so on. Those masks are not actually very good at keeping things out. They're more used by doctors so that they don't infect their patients while they're doing surgeries, and so it's better at keeping things in than keeping things out. And if you're not properly trained to use them, they're not going to work very efficiently. And if you're not sick, you shouldn't be wearing a mask in the first place. It's not going to actually help. So please stop buying those masks and leave it for the health professionals that actually need them.
It's always amazed me when you see pictures of people in China or Japan and they're wearing them either to combat smog or because of fear of health, and I'm like, well, they're not going to do either. They're not going to help you not get a cold, and they're not going to keep out the smog. They're not designed for it. So, if you want to...
Yeah, also, like, don't fall for these people, like, trying to sell you some miracle supplement that's supposed to apparently boost your immune system, because there is no such thing. Like, basically, if you want to boost your immune system, you need to eat healthy, you need to get enough sleep, you need to get vaccinated, you need to exercise, and you need to have proper hygiene. Like, that is how you boost your immune system. Like, there's no magical supplement that's going to do that.
Yeah. Actually, I did see the other day on our news, although this is one of those, I hate those. It was 7 News, and it's basically news.com or the Sun or something like that. So beautiful journalistic integrity. Anyway, they actually interviewed a naturopath on how to boost your immune system. I was fuming because exactly. I was absolutely fuming when I was watching that. That was hugely irresponsible journalism, and that's one of the biggest things that I'm furious about with the whole thing. Is that
that'd be like interviewing a flat earther to talk about space.
Exactly.
I mean,
and it infuriated me. I was so angry about that. But there was also something I brought up a few days ago as well, is that it's interesting how we as a society can look at the coronavirus and panic to the extreme. But once, because it's in front of us, it's our face, it's in our face. But when it gets into something more long-term, like global warming, I know this is going off on a bit of a tangent, and I will loop it back. That's long-term, but global warming will cause things like this to happen more and more often.
Well, we've got better incubation conditions for the viruses and other pathogens.
Yeah, and also, not to try and freak everyone out, but global warming may bring back smallpox. It's actually a genuine concern by some scientists that smallpox may be re-released into the environment because people who have died from smallpox have been buried in permafrost, and if the permafrost starts to melt, they could be unearthed and re-release smallpox into the wild.
And all the people being anti-vaxxing and all that could mean there's an outbreak.
Yeah.
Yeah.
So imagine seeing smallpox come back due to climate change.
So get your children vaccinated.
Exactly. And that's actually why we actually call it vaccines, is because smallpox was the first disease to vaccinate against, because of cowpox is basically the same as smallpox, but it is a milder version. So they would give cowpox to people, and cow vacca is cow in Italian. So that's why we call them vaccines, because vaccine vacca cow. Bit of a tidbit for you. But yeah, get vaccinated. Do not panic. As soon as you start panicking, things are going to go wrong. Listen to scientists. Don't listen to the media. Go to reputable scientific places like Nature, British Medical Journal, those kinds of places. Go read things up yourself and stop panicking. And leave toilet paper for other people.
Yeah. Please leave the toilet paper for the other people.
Please.
Shall we move on to cancer?
May as well.
I'll bring up the nature thing, Lizzy, for people to see. Where are we?
Sorry?
I will bring up the text. There it is.
So which one is it?
CRISPR-Cas9 screening reveals ubiquitous T-cell cancer targeting via monomorphic MHC class I related protein MR1. And you're going to have to explain that, Lizzy, because I've seen the video, but yeah.
It's quite a mouthful.
It is the mouthful, isn't it?
Say that 10 times while drunk.
No, I can't even say it sober 10 times.
Yeah, so I think basically most people are aware what CRISPR-Cas9 does. So basically, it's a gene editing tool that we use. So they use this specific gene editing tool. And then what they mean by monomorphic is that there is one form or one allele of a gene within a population. So there's not many different alleles or many different forms, which would then be polymorphic, of this specific gene that basically codes for the MHC. Now, MHC stands for major histocompatibility complex. I know that's also quite a mouthful, but basically, like all of our nucleated cells, so that just means like cells that have a nucleus. So like red blood cells don't really have them, but like all of the rest of our cells have the class 1 type on their surface, this MHC. And what it does is it will take little bits of like peptides and antigens of things that are inside the cell, and they will display it on the surface of the cell so that cytotoxic T cells can basically identify what is inside of the cell. And then if the cytotoxic T cell like sees, okay, there's something in the cell that's not supposed to be there because of this peptide or antigen that is now being presented on the surface of the cell by this MHC, then it will basically kill the cell so that it can kill the invader that is inside the cell. So that is like the basics of it. So what they basically did is they were actually only looking for like T cells that kill a large array of bacteria that infect our cells. And what they used is a specific cell line, which is called HeLa. Now, HeLa is a cell line that we made from cervical cancer cells, and they're actually very easily infected by bacteria. So they used these HeLa cells and infected them with a bunch of bacteria to basically see which type of T cells in humans can like attack and recognize all of these different types of bacteria. But what they found is a specific type of like cytotoxic T cell didn't just kill the cancer cells that were infected with bacteria. It killed all of the HeLa cells, so all of the cancer cells. So they basically then took this specific T cell and tested it against like a whole array of different cancers. And then they noticed that it was attacking all of the cancer cells and not the healthy cells. So instead of basically what they were looking for was T cells that kill cells that are infected by bacteria, they found this specific T cell that attacks almost all types of cancer cells. So basically, it's very what they did is they took this CRISPR-Cas9, this gene editing, and they started deleting like proteins from these cancer cells to see exactly which protein was triggering the response that the T cell could actually pick up that these cells are cancerous. And that's when they found this specific protein MR1 that was basically being displayed, so they could like pick this specific T cell had a receptor that can pick up this specific protein that is very similar in like almost all types of cancer cells. So it was actually very, very, very interesting. They tested against lung cancer, colon cancer, bone cancer, breast cancer, blood cancer, skin cancer, all of the different types of cancers. Yeah. So they basically tested it against like in mice, but with human cancers, and it's been very, very successful. And they're hoping to basically start human trials in the next few years. So it's very interesting.
It's fascinating. Quick question for you, Lizzy. Those cancer cells that they originally did the work on, they were created quite a few years ago, weren't they? And they've been constantly recultured and used because they were so useful for doing tests on bacteria and stuff, weren't they? So there's
are you talking about HeLa cells?
Yeah.
Yeah. HeLa cells were originally cultured from someone called Henrietta Lacks.
Yes, that's right.
She died of cervical cancer. Oh gosh, the 1950s or something?
Yeah, 50, 60 years ago.
Yeah, and it's a really fascinating story, but it's unfortunately neither her nor her family actually got any monetary compensation for what has happened, and the family is not very happy about it. Yeah, she's saved millions of lives, and there was a lot of ethical breaches and stuff like that. It's a very fascinating story. And I also want to say, if Lizzy and I will talk very big words, if you don't understand them, please say it in the chat, because Lizzy and I understand the word cytotoxic, but the average person might go, what the hell does that mean? And cytotoxic means deadly to cells. So if you hear any words that you're like, I don't understand, just let us know in the chat, and we'll be able to respond.
A more understood term is a killer T cell. So like in the word killer, it basically kills infected cells.
Yeah. So just putting it out there, because once scientists start talking, we forget that it's an entirely different language.
What I like is it's like the discovery of penicillin. They weren't even really looking for this. It was an accident, and great discoveries that come from accident are just amazing. I just love it. The fact that we were looking for something else, but we found this, and it's really useful. Even CRISPR-Cas9 came from an accident. So.
It's actually very interesting, because it can lead to a new type of therapy in what we call like CAR T immunotherapy. So in CAR T immunotherapy is basically, if the person has cancer, they will extract some T cells and engineer it to specifically attack the person's cancer. But those types of therapies needs to be very specific to each person and each type of cancer. But with this one, if it attacks like this broad array of different cancers, we can just take that specific like receptor that these T cells require to pick up that MR1 and then use that in CAR T immunotherapy for a wide array of cancers. So it's very, very promising.
It's almost like having a universal anti-venom, and then you only have to worry about targeted ones when that one doesn't work. So
yes, exactly.
So
it's
sense,
very interesting.
Yeah, it moves along. It moves along that field of investigation for cancer therapy very, very fast. You know, where we were looking at maybe decades to get to a point where we can treat a lot of cancers, we may be within the next decade treating most of them and then looking to specialize on the ones that we can't get with this. So it's a big jump forward, provided it pays off, but it looks like it will. So
cancer is an extremely difficult type of disease. Like that, no one has cancer. Everyone has a type of cancer, and it's very, very difficult to heal and to fix, especially if you have relapses, because cancers also have a form of natural selection as well. So, for example, if you are receiving immunotherapy, or if you're receiving some form of cancer treatment, the cancer may be killed by this particular type of treatment. But if it mutates, and cancers mutate quite well, the DNA in cancer mutates quite quickly compared to other cell cultures, because they grow quicker and they divide quicker, and therefore they're more likely to mutate. Cancers can, if they do relapse or they do come back, sometimes don't respond to the same treatment because they have mutated resistance, just like antibiotic resistance, within the body. And so a person can have different types of cancer within their body, because those cancers have branched off just like a phylogenetic tree. So that's one of the problems with fighting cancer. That's why we haven't found a cure to cancer. But also, what we're also forgetting is that cancer, there's no such thing, well, there's very rarely in science a leap forward. It's always incremental steps going forward and forward towards curing cancer. So 15, 20, 30 years ago, the survival rate for one type of cancer might have been, 4 or 5 years, but now the prognosis might be 30 or 40 years due to slowly incremental steps. So I don't think anytime soon we're going to be able to go, oh, you've got cancer, here's a pill, you are now completely free of cancer. But when you do we are going to eventually get to the point where most cancers are curable, and quite well. So, and this is one of the examples of how we can do that, by using our own defense mechanisms, such as our killer T cells, to attack our own the cancer cells. So
yeah. I mean, the processes to get to curing cancers is going to be complicated. This isn't simple stuff. It's not a pill, as Mary said.
No.
It's a gene therapy that's we are actually taking out the bits we need from T cells, putting them in the person's T cells, and then re-injecting them into the person, basically. So we're manufacturing these super T cells for them. So in that sense, the therapy is still specialized to the individual, but it's not having to be as specialized as it was when we were doing a targeted therapy. So that has saved an awful lot of years of research to hopefully target these quite numerous numbers of cancers. So that's a good thing, and it is good. It's good that we'll get like that. I mean, maybe in the future, if we ever, we're starting to experiment with biological nanobots. If we can get to the point where we can manufacture our own type of nanobot T cell that helps our immune systems, we may be in a position where we are actually defeating cancer properly, and
Yeah.
nobody ever has to worry about that. But that's a very, very long way down the track. We are right at the beginnings of that. But
we are currently there's a lot of people doing not nano like technology as in AI and so on, but like nanoparticles. So it's just means like extremely small particles of something. So they've been taking like nanoparticles of silver and copper and so on, and basically using those little particles, the nanoparticles, to coat it in antibiotics, and to see if that's coating the nanoparticle with antibiotics actually increases its efficacy. And it has shown a lot of very good results. So it's not technically the nanoparticle itself that's having this antibiotic effect, but just coating the nanoparticle with antibiotics or something that is geared towards treating a certain disease, just coating it, like making sure that there's a larger surface area and so on for these like antibiotics to go into the body and like travel through all the systems. So it's been very interesting.
Yeah. And there's one thing that has been a bit of a blessing when it comes to cancer is that every single cancer produces one specific glycogen, which is a sugar attached to a protein attached to the surface of the cell. And every single cancer, doesn't matter what type it is, if you've got this, produces this particular glycogen, where, you know, one of the ways that they're thinking about attacking cancer is being able to genetically modify a virus to attack that particular glycogen. So they, again, going back to the whole jigsaw piece analogy, the virus can only attach to this one particular glycogen, and will be sucked into the cell, and this virus will kill this cell. But easier said than done. Things like this take years and years and years and years of research. So, but that's one way that they're attacking it. I did read somewhere that they're thinking about using bee venom. There's something in bee venom that attacks cells. But we've also got to remember, if something works really well on a petri dish, 99.9999 times out of 100, or something very huge amount of time, if it works on a petri dish, it won't work in the body. That's the same reason why a lot of promising technologies fall apart, because as soon as you scale them or put them into a different situation, they don't work. So that's something else that you need to understand, is that if you read something that says in 5 to 10 years, it's more likely going to be 15 to 20 years, unfortunately, because there's always those stumbling blocks that they don't know that they're going to come across. So something like this, with the T-cell thing, is fantastic news, but when they say 5 to 10 years, in 10 years' time, they're more likely going to say 5 to 10 years, which is a bit of a joke.
The whole viral treatment actually brings me to like the second study that's being done in Australia, where they have basically taken the cowpox virus and engineered it into something they called CF33 to try and target that specific glycoprotein, which is on cancer cells. So they have tested it on a few different cancer cells as well, but mostly just in, like Nervardia said, in petri dishes. And when they tested it in mice, it did shrink the tumors, but they have yet to move to human trials. So they basically engineered this cowpox virus to specifically try and attack a variety of different cancer cells.
And that's the thing. If we have multiple treatment systems, and hopefully they will correlate to going across to humans, if we have multiple attack systems, we have a better chance of offering people a cure. We can target individuals.
Yeah, because as I said earlier, if a treatment works on one, if it doesn't kill it off, it's a bit like an antibiotic resistance, but within the person's body. It's like there's different types of cancer. So if we can get a multi-pronged attack on a person's cancer, they're more likely to be in remission for the rest of their lives.
It's very good that different people are taking different approaches. So like the one study is looking at basically engineering your T cells, and the other study is looking at engineering like viral cells. So if we have like different treatment lines, it would be better for the efficacy if we have like different areas and sites that we want to attack the cancers and not just like one straightforward thing.
Yeah. I mean, because a treatment that works in 80% of patients still has 20% of patients it's not going to work in. If you've got multiple treatment types, your chances of being able to cover everybody with your different treatments is a lot higher than if you've just got the one. So just because you go, oh, we've got a really good possibility and maybe it works in 80% of people, let's stop researching. No, that's not how this ever works. We keep looking for more ways that we can make better health outcomes. If we just stop with penicillin, then, I mean, we have problems now with antibiotics, but if we just stopped at penicillin, imagine where we'd be. We'd be back like we were 150 years ago, where people were dying from small infections.
Yeah. So that's scary thought, but we do need a multi-pronged approach, and that's the same with any problem that we have. I mean, there's no such thing as a silver bullet. Like, going off on a tangent, but it makes sense. This tangent makes sense. Like renewable energy, everyone goes, well, what if the sun doesn't shine, or what if the wind isn't blowing? Oh, it's like, well, then you have both the solar panel and the wind turbine, and then you have battery storage. Like, we can't just rely on one thing, which is what we've been doing with coal. And look at look at the world now. Like, it's basically on fire because we've relied so heavily on coal. So silver bullets do not exist at all. And there's false equivalencies happen all the time, but we got to remember multi-pronged approaches to a problem such as cancer, climate change, coronavirus, anything like that needs to be attacked, because if one fails, then you've got backups.
Yeah. You got anything to add, Lizzie?
I think we've covered mostly anything. I just wanted to say, like, with regards to the coronavirus, which is like circling a little bit back, but there is actually currently like 80 different clinical trials taking place, like trying to find different treatments. They've been testing antivirals, antiretrovirals, HIV medication, taking antibodies from the plasma of people that have already been like recovered from the disease that have antibodies. So there's like a large array of studies going on to try and find like something that can help combat the coronavirus, in addition to them trying to find a vaccine.
And the reality is, by next flu season around, it'll probably be part of the things that you get vaccinated for.
Yeah, it will most likely be.
It'll be one of those things that it's a worry for now. It may kill quite a few people, and that's dreadful. But you've probably got more chance in dying when you get in your car tomorrow than you have of dying of coronavirus.
Yeah,
and that's the reality.
But also, again, the silver lining when it comes to things like coronaviruses and outbreaks and things like that, we actually go necessity breeds innovation.
Yeah.
Because one of the spokespeople for the World Health Organization said, in 8 weeks we have done this, and this, and this has never been done before at this speed. And that's fantastic news. And Lizzie, you were talking about things with HIV. I think I remember reading something about HIV being used, and HIV things that they've learned from HIV to help people with other diseases, and I think even maybe cancer. I'm not sure. I'm just dragging it out of my memory, so you're going to have to double check on this one. Do not take my word for this, but HIV studies have helped with other diseases, and some HIV treatments help with other diseases. So when you're looking at things like the coronavirus, cancer coming out, whatever, it will always have a flow-on effect to support something that you wouldn't even have thought about. That's why whenever I hear people go on and say, why are we bothering doing space exploration or whatever, because we don't know what those innovations are going to come up. And it's the same with cancer research, because a lot of people do argue that female-centered cancer research, that there's a lot of people, like there's a lot of funding towards things like breast cancer and cervical cancer, and what about other cancers? But the thing is, the majority of a lot of the things that they find in breast cancer, cervical cancer, they actually can use that information found to help with other cancers as well. So it's kind of like, scientists talk to each other. It's kind of weird. So
the scientific community is one of the most sharing and border-breaking communities in the world. It just is like that. We don't care about different cultures, and we don't care about country borders so much because science is about sharing knowledge.
There's Russians and people from the US up on the International Space Station working together.
Yeah.
Are you okay, Lizzie?
Yeah, no, I'm good. I just had a little bit of a cough, so I had to turn off the mic there for a second.
Well, I think we've almost come to a good conclusion to this, just about. Unless you got anything to add, Lizzie or Mary? So.
No. What about the difference between MHC class 1 and MHC class 2 proteins?
Oh, okay.
Because that's probably something I should know about.
Lizzie?
So basically it's just like the MSC class 2 ones are not found on all of our nucleated cells. They're more specific in the type of things that they basically show our immune system, whereas the MSC class 1 proteins are found on all of our nucleated cells, and they just like pick little bits of things that are in the cell to like displayed to the immune. So it's just basically the specificity and then on how many different cells they are actually found. So the MHC class 1 is found on like all nucleated cells, and it just shows like little bits and pieces of things that are inside of the cell to the immune system, whereas the MSC class 1 is found on a very limited line of cells, and they're more specific in what they basically display.
Do we have any questions from the chat? Because I haven't been paying as much attention to the chat as what I should be, and I apologise for that. If we have some questions, we'll ask them.
Well, hi everybody, by the way. Yep. I've seen Orla, starting Chris, Bo, Eliana, more Orla.
Your other half.
Yeah, or whatever.
Randy, Bo.
Critical. So hello everybody.
Hello everyone.
Hey Miss India, how you going?
And best name. Christine.
Best name ever.
Yeah.
Also, Miss India says cancer runs in my family, which is absolutely horrendous.
Mine, so
it is very. I'm sorry to hear that. The majority of cancers are actually due to environmental factors, but there is like a 5 to 10% of cancers are actually genetically predisposed. People still get lung cancer even if they haven't been smoking. So if you meet somebody who has lung cancer, please don't assume they've been smoking. It's a very, very awful thing to say to somebody who's never smoked a cigarette in their life that they deserve to get lung cancer.
Likewise, if you meet someone with skin cancer, don't just assume they spend all their time out in the sun without sunscreen, because you can get skin cancer without doing that.
Yeah, so just don't assume things. That's probably
not you said you hate
one
him.
of them. Not really, not overly.
Only a little bit.
I love you, man. You know that.
It doesn't look like we're getting any questions, so it looks like we covered everything.
I'm glad everyone in the chat is now cancer experts.
Yes, yeah. You've given them a biology lesson.
It's a joke. Yeah. It's a joke.
Yeah. If you want to hear more about cancer, I do listen to a really good podcast called Skeptics with a K. One of the hosts is actually doing a PhD in cancer. She's a very, very intelligent woman. So, yeah, listen to Skeptics with a K. And if you want to listen to another really awesome science podcast, I suggest the Skeptic's Guide to the Universe as well. They also do occasionally talk about cancer as well. So that's where I get a lot of my science info. So I strongly suggest those two.
Yeah, best name ever. If
people
they
want
took a
to
cell sample,
stay up to date.
If they take a cell sample,
if people want to stay up to, if people want to stay up to date with the coronavirus outbreak, there is a YouTube channel called Dr. Mike. He actually gives out weekly updates, and he's also one of the people that is trying to bring down the panic.
Yeah. Stop panicking.
Yeah.
Stop listening to the media.
And best name ever, Kristen, I think it is. Sorry, Kristen. I apologize. Yeah, if they took skin cell samples from you before Christmas, with the idea of seeing if you had cancer, you would have had a phone call by now if it was cancer. Most of the labs and doctors are pretty thorough if you show a positive on a test, and drag their feet if you don't.
Yeah, that's good, because I actually had an experience this year and a bit ago, where I had a scare, and they got me from diagnosis of the thing that I won't go into it because I don't want to talk about it. But I went from the diagnosis to the operating table in a month, because there was a 3 to 5% chance that it could be cancerous. Thankfully it wasn't. It was just something that they cut out and it was all good. But yeah, so thankfully doctors, once you've been diagnosed, will get on top of that pretty damned quickly.
Yeah. It's not something they want to drag their feet with.
No. Even if it's a tiny, tiny, tiny chance of it being cancerous, they would rather cut it out just in case.
Cut it out.
Yeah. So are there any other questions or anything, or are we going to bugger off?
What Bo said, skin cancer usually hits pretty random. Don't actually know if it's less common in black people as well as mostly white. So no,
I think dare say.
Well, mostly white. No, skin cancer is just as common in black people as white people. Your extra melanin might protect you from sunburns to a certain extent, but the skin cancers still happen. The UV light gets through anyway, and that's what mutagens the cells, and that's what can lead to the cancer. So having the darker pigment might stop some of the infrared, which is what warms your skin up and gives you your lovely burn, but it doesn't stop the UV. So
yeah, KCA Randy, yes, Mike Marshall is on that podcast. Yeah, and Alice, I can't remember her last name. She's the one that does the cancer studies. So yeah, I strongly recommend listening to it. Unfortunately, there are no Australian versions of that podcast, so that needs to change.
Maybe we should fix that, Mary.
Orla said that for me, I had a cyst on my ovary that had gotten really big and twisted to cause a lot of pain. I'm really sorry to hear that. I really hope you got help. Like ovarian torsion is extremely painful, and it can happen if you have cysts. Yeah, it can definitely happen if you have cysts. But just like most cysts are not cancerous at all, and they normally like sort themselves out.
4 kilogram worth of cysts, Ola said.
Well, that's impressive.
Yeah,
that's impressive.
Yes,
I know somebody who had a contorted ovary from a that was not fun. That was not fun. She could have died. So yeah,
it can happen, especially if you are undergoing things such as IVF treatment, where they basically overstimulate your ovaries to get a lot of eggs. And sometimes you can get something which is called like ovarian hyperstimulation syndrome, which can lead to ovarian torsion. So it is definitely a life-threatening condition because it like cuts off blood supply, and it can lead to like leakages of like the fluids in your ovaries to other parts of the body. So like definitely if you are concerned, like please go see a doctor. Please go see a doctor.
Same for anything. If you are feeling unbelievable pains in your body anywhere, go and see a doctor. Don't just put up with pain. Pain is usually a sign that something is wrong.
Yes, that is very true. All right.
I think we've got through all the main questions there. All the questions.
Yeah. I think so.
Well, thank you, Lizzie, for joining us and educating us.
It was very, very interesting. I'd like to try and get you on to my channel so we can geek out over bacteria.
That seems like a great video.
Definitely. Oh, definitely. I love my bacteria. I actually specialize in I actually specialize in working with actinomycetes. They're my favorite little like subclass of bacteria. They produce all kinds of wonderful like bioactive molecules. So I work with them quite often. Lots of fun.
This is so going to be a good geeky stream when you guys do that.
Oh yeah.
Yeah. Sounds awesome.
Did you watch?
I do apologize for my crappy internet. It's been raining a lot lately, so it just worsens the internet when the weather is crap.
I'm glad I was doing it through OBS and we weren't messing around just trying to use StreamYards, because that would have made this impossible. And the fact that we could bring you in separately using Discord, whilst Mara and I use StreamYards at the same time, just made it so much better. And it means I'm probably going to have to produce for you when you do get Lizzie on, if Lizzie's still having problems.
Probably.
Yeah. That'll be fun. I can be in the background. And I can watch the
definitely.
Chat and interrupt you guys to make sure the chat comes in. So that'll be work.
Fair enough.
Thank you so much, Lizzie. You have your own channel now too, don't you, Lizzie? Your own YouTube channel.
Sort of. I just basically opened the channel because I've been suffering with something called PCOS, which is polycystic ovarian syndrome, which has basically like impeded my ability to get pregnant, and my husband and I have been trying for about 2 years now. So that was just like basically me explaining like how it was affecting me and what it is, and all of this. But I do plan on in future, like making more like science-based things once I can get my internet situation a bit better, because like those 2 little small videos that I have on my channel currently took me about 8 hours to upload.
Oh.
Jeez.
Yeah.
God.
No, we do.
We
have better
complain
internet than
about
you.
ours. Jeez.
No, that's pretty dreadful. But people should go. I believe Dave's been posting everyone's details. I have got links in the description. I don't think I put Lizzie's YouTube channel in the description because I forgot you have one. To be perfectly honest, Lizzie, I totally forgot.
No, it's no problem.
So please go and follow Lizzie on Twitter and sub to her YouTube channels to get more science stuff when Lizzie's finally able to post it. And what have you got on, Maro? Because
I am bringing back a old favorite.
Ooh.
I am having a conversation between Godless Strayan and Mary Magdalene.
Oh, lovely.
Yeah. So that's been an interesting video to edit, but yeah.
Sounds great.
Godless Strayan has come back for a quick, but I won't say what the conversation is on, but it is based on a conversation I had with a person on Twitter, and a lot of the arguments that they made, I put into this video because they were weird arguments, I would say.
I'm pretty sure everyone who follows me or watches my videos knows Maro and is subbed already, but if you're not, go and subscribe to Maro. Because what the hell are you doing? Basically. I should have a video out in a few days. I'm not going to go into too much details of what it's about because I'm still researching stuff for it, but it'll be a bit more sciencey than my normal takedown videos on people, because I think I've done enough of I will do those occasionally still, but I think I've done enough of that, and I'm enjoying doing these discussion videos, either this or with Amanda with Critical Bitches. And if you missed last night's Critical Bitches, please go and catch it up after this because it was awesome fun. And yeah, I just want to bring out a bit more of my field in science with stuff like this in to do with maths and physics and computer science as well. So I'm going to be bringing a bit more of content of other things I'm interested in, other than harassing people because they're stupid. I'll
There's
still do that
wrong with that,
because it's good fun to do, but I won't be doing it all the time. So people can look forward to that. So thank you for joining me, Lizzie and Maro, and
thanks for having me on.
Oh yeah, it's been awesome. And thank you to everyone in the chat for joining us, and we will catch you in the next one. And don't forget to look out for Maro's discussion with Lizzie coming soon.
If we get there.
All right, bye everyone.
Bye.